Chapter 11, Section 2, Areas of Regular Polygons. The area of an equilateral triangle theorem states that the area of an equilateral triangle is 1/4 the square of the length of the side times the square root of 3. Here I have A equals 1/4 the square root of 3 times s squared. The first example says to find the area of an equilateral triangle with 10 centimeter sides. They've given me my side length, so I need to plug in 10 for s. So area equals 1/4 the square root of 3 times 10 squared. 10 squared is 100, so area equals 1/4 the square root of 3 times 100. I can combine 1/4 and 100, and I'm multiplying them. Remember that multiplying by 1/4 is the same as dividing by 4. So the area is 100 divided by 4 times the square root of 3. 100 divided by 4 is 25 times the square root of 3 centimeters squared is my answer. This would be the exact area of this equilateral triangle. If they asked for my answer as a decimal, I could plug in 25 times the square root of 3 into my calculator and write my answer as a decimal. But for now, we're going to leave it as an exact answer. The next question asks us to find the area of an equilateral triangle whose perimeter is 6. If the perimeter is 6 and I have an equilateral triangle, I can divide 6 by 3, and you have a side length of 2. Now I'm ready to plug in 2 for s, so area equals 1/4 the square root of 3 times 2 squared. 2 squared is 4, so area equals 1/4 the square root of 3 times 4. Again, I can combine 1/4 and my whole number 4. So the area equals 4 divided by 4 times the square root of 3. Well, 4 divided by 4 is 1, and 1 times the square root of 3 is just the square root of 3. So the exact answer to my question would be the square root of 3 inches squared. We're going to learn how to use triangles to find the area of regular polygons. We have formulas to find the area of triangles and most quadrilaterals, and now we're going to have a way to find the area of other regular polygons. If you think of a regular polygon inscribed in a circle, remember inscribed means that all of the vertices are points on the circle. Here I have a regular heptagon. You can have any regular polygon. If you draw the center of the circle, that's also the center of the polygon. So here, this point is the center of the polygon and the circle. If you draw a segment from the center to a vertice of the polygon, you'll notice that it becomes the radius of the circle. So we're going to call this segment the radius of both the polygon and the circle. The distance from the center to any side of the polygon is called the apothem of the polygon. So here, this line goes from the center to the side of my polygon. So this dotted line would be the apothem, and the apothem is perpendicular to your side. The apothem is the height of a triangle between the center and 2 consecutive vertices of the polygon. So if I draw a consecutive radius, and now I have 2 consecutive radii, the apothem would also be the height of the triangle formed. A central angle of a regular polygon is an angle whose vertex is the center and whose sides are 2 consecutive radii of the polygon. I'm going to look at my heptagon again. And if I have an angle whose vertex is the center and whose sides are 2 consecutive radii, like I do here, I can to find the measure of the central angle, you're going to divide 360 by the number of sides of the polygon. So to find the measure of this blue angle, I could take 360 and divide it by 7 because I have a heptagon, and I know that that angle would measure 51.43 degrees. The apothem is going to bisect the central angle and is a perpendicular bisector to the side of the polygon. The area of a regular polygon theorem states that the area of a regular polygon with side length S is half the product of the apothem A and the perimeter P. So area equals 1/2 the apothem times the perimeter. If you break this down a little bit more, this is the same thing. I've just, instead of saying perimeter, I'm saying N times S. So the area of a regular polygon equals 1/2 the apothem times N, the number of sides, times S, the side length. The first example says a regular octagon is inscribed in a circle with a radius 4 units. Find the area of the octagon. I'm going to go ahead and draw a picture of what I know. So here I have an octagon inscribed in a circle, and I have a radius of 4. A tip here is that anytime you're only given one side length, you're going to need to use the central angle, and you're going to need to use your trigonometric ratios to find your missing sides. Remember, the trigonometric ratios are sine, cosine, and tangent. So I'm going to go ahead and draw another consecutive radii. Find the measure of the central angle. In this case, I have 8 sides because it's an octagon, so I need to take 360 and divide it by 8. And when I do so, I find that my central angle measures 45 degrees. Now, when I am using this theorem, it's going to be helpful to draw a picture of just the triangle and what you know. So I'm going to pull out this triangle. Notice that I've labeled my 2 sides 4 because that would be the radius, which they tell me is 4. I need to find the apothem to plug into my theorem. I know that the whole central angle is 45 degrees. The apothem cuts that central angle in half, so this half of the angle would be 22.5 degrees. Notice that the apothem is forming 2 right triangles, and I'm going to be able to use those right triangles to use the trigonometric ratios. I know that the hypotenuse is 4, and I want to find the apothem. So, using my 22.5 degree angle, I know the hypotenuse is 4, and I want to find the apothem, which would be the side adjacent to the 22.5 degree angle. The trigonometric ratio that uses the hypotenuse and the adjacent would be cosine. So I can say that cosine of 22.5 degrees equals A, the apothem, over 4, the hypotenuse. To solve for A, multiply by 4 on both sides, and you know that your apothem is 4 cosine of 22.5. For right now, I'm going to leave it as 4 cosine of 22.5. Now I need to find my side length. I can use this same right triangle to find x, but notice that x is only half of your side length. So when I find x, I'm going to need to multiply by 2 to find the whole side length of your octagon. Now I'm going to use the sine of 22.5 equals x, which is the side opposite, over 4, the hypotenuse. I need to solve for x, so multiply by 4 on both sides. 4 times the sine of 22.5 equals x. Remember, this is only half of the side, so I need to multiply by 2 or double that, and I get 8 sine of 22.5 for my side length. Now I'm ready to use the theorem. Plug in the apothem, plug in the side length. I know that the number of sides is 8 because this is an octagon. So area equals 1/2 the 4 cosine 22.5 times 8 times 8 sine of 22.5. Well, half of 4 cosine 22.5 is 2 cosine 22.5, And 8 times 8 sine of 22.5 would be 64 sine of 22.5. Plug this into your calculator, and when you do, you get about 45.25 square units because I'm talking about area. The next example says the bottom of a glass is a regular 12-gon with a side length of about 1.2 centimeters and a radius of 2.3 centimeters. What is the area of the bottom of the glass? I know that I have a 12-sided polygon, and I know that the side length is 1.2 and the radius is 2.3. So I've gone ahead and I have labeled that in my picture. Go ahead and pull out your triangle and keep what you know labeled. The only thing that I need to solve for is the apothem. So draw in your apothem, and remember that the apothem is going to bisect your side. So I know that this part of the side, or this leg of the right triangle formed, is 0.6 centimeters. Notice that you know the hypotenuse, you know one leg, and I'm missing just the apothem, just the other leg. So I'm going to be able to use the Pythagorean theorem to find A. A squared plus 0.6 squared equals 2.3 squared. Go ahead and square the numbers. Now I need to subtract 0.36 from both sides, and I need to take the square root of both sides to solve for A. So A is the square root of 4.93. So there is my apothem. My side length is given to me. It's 1.2, and I know that the number of sides is 12. I'm ready to use the theorem. Area equals 1/2 the square root of 4.93 times 12 times 1.2. Plug this into your calculator and you get about 16 centimeters squared. The next example says, what is the area of a regular 9-gon with a side length of 6 inches? Go ahead and draw yourself a picture. You're given one side length. Remember, when you're only given one side length, you're going to need to use your trigonometric ratios to find the missing side lengths. I have to know an angle to use the trigonometric ratios, and I can find an angle, I can find the measure of the central angle. Here I have a 9-sided polygon, so I take 360 and divide it by 9 and get 40 for the measure of the central angle. Draw yourself your triangle. Go ahead and draw in the apothem because that's what we need to find. I know that the apothem bisects my central angle, which was 40, so this part of the central angle is 20. Remember that the apothem also bisects your side, so this part of the side would be 3, and I want to find A. So you looking at the 20-degree angle, I know that the opposite side is 3, and I want to find the apothem, or the adjacent side. So in this case, I need to use the tangent of 20 equals 3 opposite over A adjacent. When you solve for A, you get 3 divided by tangent 20. So there is my apothem. My side length is 6, and I'm ready to plug in what I know. So area equals 1/2 3 divided by tangent 20 times 9, the number of sides, times 6, the side length. When you plug this into your calculator, you should get about 222.5 inches squared. Today's assignment is on page 672. I want you to work on numbers 1 through 8 and 10 through 24 even.